Welcome to Module 1, Introduction to High-Performance Cleaning Systems. Let's start with a question. What do you actually do for a living? If your answer is I clean buildings, we're going to gently challenge that today. Because what a high-performance cleaning specialist does is something far more significant. You protect the health of everyone who walks into that building. You preserve the value of the facility. And you do it through a disciplined, science-backed set of practices that most people never see and rarely appreciate. That shift in how we think about our work, from reactive tidying to proactive health protection, is what this whole module is about. Let's unpack it. There's a simple way to see the difference between traditional cleaning and high-performance cleaning. Think of it as two different triggers. In traditional cleaning, we act when something looks dirty or when someone complains. We're always playing catch-up. In a high-performance system, we work to a scientifically designed schedule that prevents soil and pathogens from building up in the first place. We're not reacting to problems, we're stopping them before they start. The slide ahead shows this as a side-by-side comparison. On the left, the reactive approach. On the right, the proactive mindset we're building together. So what exactly is high-performance cleaning? Here's the working definition we'll carry through this course. It's a structured, evidence-based approach that brings together the right people, the right tools, and the right processes. Not guesswork. Not habit. Trained specialists, ergonomic equipment, and documented standard operating procedures, what we call SOPs, that are grounded in the science of cleaning and disinfection. The result is something measurable. Cleaner air, healthier buildings, more efficient operations, and a system that consistently delivers quality, regardless of who's on shift that night. Let's make this concrete. Imagine two people cleaning the same restroom counter. The first gives it a quick wipe with whatever cloth is handy and moves on. It looks clean. But looks aren't the same as clean. The second, the HPC specialist, works through a deliberate sequence. They select the right certified cleaning solution from a dilution control station. They apply it and wait, letting the disinfectant do its work for the full required contact time. They use a yellow microfiber cloth, yellow, because that's the designated color for lower-risk restroom surfaces like counters. And when they're done, that cloth goes straight into the laundry bag. It doesn't go back in the pocket. It doesn't get used on the next surface. Same counter. Very different result. Let's talk about one of the most important and most overlooked concepts in cleaning science. It's called dwell time, sometimes called contact time. Dwell time is the length of time a disinfectant needs to stay visibly wet on a surface to actually kill the pathogens listed on its label. This isn't a suggestion. It's a scientific and legal requirement. Here's the problem. The single most common failure in disinfection is spraying a surface and immediately wiping it dry. You've removed the visible dirt, but the germs, most of them are still very much alive. Every disinfectant registered in South Africa has its required dwell time on the label. It might be 30 seconds for a fast-acting product, or 10 minutes or more for others. Knowing that time and respecting it is one of the things that separates a specialist from a traditional cleaner. Dwell time isn't just a waiting game, it's actually a tool we can use to work smarter. Here's how. When we enter a restroom, we don't spray one surface, wait, wipe, and then move on. We spray all the high-touch surfaces first, the toilet, the flush handle, the sink, the taps. Then, while the chemistry is doing its work, we get on with other tasks, emptying the bin, restocking paper towels and soap, cleaning the mirrors. By the time we circle back to wipe those sprayed surfaces, the dwell time has been met. The disinfectant has done its job. We've cleaned efficiently and correctly at the same time. Now let's look at cross-contamination. This is the process of accidentally moving pathogens from one surface to another, through our cloths, our mops, our hands, or our equipment. It's the #1 enemy of the HPC specialist, because it can turn a cleaning process into a germ-spreading process. We think we're making a place safer. But if we use the same cloth on a toilet and then on a kitchen counter, we've done the opposite. The good news is that we have a powerful, simple system to prevent this. And it's built around color. The color coding system makes cross-contamination prevention almost impossible to get wrong, as long as we follow it consistently. The slide here shows a 4-color breakdown. Red cloths stay in the high-risk restroom areas, toilets, urinals, heavily soiled surfaces. They never leave the restroom. Yellow is for the lower-risk restroom surfaces, sinks, counters, mirrors. Blue is for general office and public spaces. And green is exclusively for kitchens and food preparation areas. The logic is straightforward. Red never touches blue. Green never touches yellow. Each color is a firewall. And the rule that goes with it: once a cloth has been used, it goes into the laundry bag. No reusing until it's been properly washed at the correct temperature. The third core concept we need to understand is ergonomics, and this one is about protecting you. Ergonomics is the science of fitting the work to the worker, not forcing the worker to fit the work. In a physically demanding job like ours, it's the difference between a long, healthy career and chronic pain that ends it early. High-performance systems are built around ergonomic tools: lightweight backpack vacuums instead of heavy uprights, microfiber mops that need far less water and far less force, and automated chemical dispensing systems that mean we never have to lift and pour heavy containers. But tools are only part of it. How we move our bodies matters just as much. Good body mechanics isn't complicated, but it has to become habit. When we mop or vacuum, we adjust the handle so our back stays straight. The power comes from our legs and core, not from bending over. When we lift heavy bins or move equipment, we bend our knees and lift with our legs. We never twist while lifting. And we pay attention to repetitive stress. Doing the same motion for hours, wrist, shoulder, elbow, adds up over time. We vary our tasks through the shift where possible, and we take short stretch breaks as our SOPs recommend. These aren't optional extras. They're how we make sure we can still do this work in 10 years' time. Everything we do as HPC specialists is anchored to 4 core goals. We call them the 4 pillars, and they give our work its purpose and its direction. The first pillar is quality assurance. The second is health and safety. The third is efficiency and productivity. And the fourth is environmental responsibility, what we also call sustainability. Every task we perform supports at least one of these pillars. Often it supports all 4 at once. Let's look at what each one actually means in practice. Quality in HPC doesn't mean doing our best today. It means that a classroom cleaned on Monday by one specialist meets exactly the same standard as one cleaned on Tuesday by someone else. Quality is consistent, measurable, and defined by our SOPs. Our role here is clear: follow the procedure in the right sequence every time. The SOP isn't bureaucracy. It's the blueprint for quality. Skipping a step, even a small one, can undo the steps before it. Wiping a desk before dusting the monitor above it. You've just recontaminated the surface you cleaned. That's why we follow the sequence. Every time. The second pillar reminds us of our real purpose. We are frontline public health professionals. When we clean for health, not just for appearance, we're actively reducing the spread of illness in the buildings we service. Fewer sick days. Fewer colds passing from desk to desk. Fewer serious infections in high-risk environments like schools and healthcare facilities. Our role here includes correct PPE, use every shift, understanding the safety data sheet for every chemical we handle, and following infection control procedures, dwell time, color coding, hand hygiene, without shortcuts. Our work has a direct and positive impact on the health of every person in that building. Efficiency in HPC isn't about rushing. It's about eliminating wasted time and motion so we achieve more, with less effort, without ever dropping our quality standards. The way we get there is structure. A fully stocked cart before we start our route. A proven task sequence for each area we clean. Ergonomic tools that let us work faster and with less fatigue. And here's the benefit for us directly. An efficient system is a less stressful system. We're not constantly figuring out what to do next. We're executing a well-rehearsed plan. We finish the shift feeling accomplished, not wrecked. The fourth pillar is about the world outside the building. As HPC specialists, we are stewards of the environment, and that responsibility shows up in the small decisions we make every day. Using certified green cleaning chemicals protects South Africa's water systems. Using a HEPA filter vacuum prevents allergens and harmful dust from circulating back into the air. Separating waste correctly reduces what ends up in landfill. And using microfiber technology, which we'll come to shortly, can cut water usage for mopping by over 90%. Every one of those actions, no matter how routine it feels, contributes to something real. Let's move into an area that often surprises people: indoor air quality. We spend roughly 90% of our time indoors. And the air inside buildings can carry dust, mold spores, allergens, bacteria, and chemical residues, all of which get inhaled. Poor indoor air quality has been linked to allergies, asthma, headaches, fatigue, and long-term respiratory problems. Here's the key distinction for us. There's a big difference between removing dust and relocating it. A dry feather duster doesn't clean, it just moves particles into the air where they float for hours. In HPC, we remove dust. We don't just shift it around. The two tools we use to actually remove dust, rather than redistribute it, are damp microfiber cloths that capture and lock particles within their fibers, and professional vacuums equipped with certified HEPA filters. HEPA stands for High Efficiency Particulate Air. A true HEPA filter captures 99.97% of particles, down to 0.3 microns in size. To put that in perspective, a human hair is roughly 60 microns thick. These filters are catching things far too small for us to see. Before every shift, we check that the vacuum bag is not full, that it's properly sealed, and that the HEPA filter is correctly fitted and clean. A clogged or missing filter turns our vacuum from a cleaning tool into a pollution machine. Green cleaning isn't a trend. It's the professional standard, and it's what HPC requires of us. The goal is to use products and processes that cause the least possible harm to human health and the environment. That means certified chemicals, not whatever happens to be on the shelf. In South Africa, the labels we look for include Green Seal, UL Ecolago, and EPA Safer Choice for internationally certified products, and the SABS mark for locally tested products. These certifications mean a product has been independently tested against strict standards for safety and environmental performance. A practical rule: if a chemical has a strong artificial fragrance that lingers, it's likely releasing high levels of volatile organic compounds, VOCs, into the air. That's a red flag, not a selling point. One of the clearest signs of a high-performance operation is how chemicals are handled. In HPC, we use a wall-mounted dilution control station, a DCS, or pre-measured packets for all our chemical needs. Manual pouring is strictly off the table. Why? 3 reasons. It's dangerous. Direct contact with concentrates can burn skin and eyes. It's wasteful. People almost always pour too much. And an over-concentrated solution doesn't clean better. The soap residue it leaves behind actually attracts more dirt. It's called resoiling, and it means we're making our own job harder. Our job is to use the DCS exactly as trained. The right product, the right dilution ratio, the correctly labeled secondary container. No shortcuts. Let's talk about microfiber, because it's one of the most powerful tools in our kit, and it's worth understanding why it works. Microfiber is a synthetic blend of polyester and nylon, woven from fibers many times finer than a human hair. During manufacturing, those fibers are split, creating millions of tiny hooks and loops. When we wipe a surface dry, the static charge that builds up attracts and holds onto dust particles like a magnet. When we wipe damp, the capillary action pulls liquid and soil up into the fibers, leaving a cleaner, drier surface behind. That's not marketing language. That's physics. Knowing how microfiber works, we can see why the folding technique matters so much. A standard 40-centimeter cloth, folded in half and then in half again, gives us a pad with 4 cleaning surfaces on each side, 8 surfaces in total. We use 1 surface per defined area. When it's visibly soiled, we refold to a fresh surface. When all 8 surfaces are dirty, the cloth goes into the sealed laundry bag. This is how we ensure we're always cleaning with a clean tool. This is how we prevent cross-contamination between surfaces. And this is why we never wash microfiber with cotton, and never use fabric softener. Both destroy the very structure that makes microfiber effective. Now let's shift to the economics of how we work, starting with something called a production rate. A production rate is the amount of time it should take a trained specialist to complete a specific task to a defined quality standard. These aren't arbitrary numbers, they come from rigorous industry testing, including resources like the ISA official cleaning times. For example, the production rate for vacuuming an open office area with a backpack vacuum might be 1,200 square meters per hour. That's the benchmark for a trained specialist using the right equipment and following the correct procedure. Production rates matter because they take guesswork out of scheduling. They give supervisors an objective basis for building workloads, and they give specialists a clear performance target that's fair and achievable. Production rates are the building blocks of workloading, the process of calculating how much work fits into a shift, and how many staff hours a facility actually needs. The formula is simple. Take the total area to be cleaned, divide it by the production rate, and you get the hours required. So if we need to vacuum 6,000 square meters, and our production rate is 1,200 square meters per hour, that's 5 hours of vacuuming. If a specialist is consistently taking much longer than that, it's not an immediate reason for concern, it's a signal to investigate. Is the equipment faulty? Is there an unusual amount of furniture to navigate? Does the specialist need support on technique? Workloading turns problems into questions, and questions into improvements. Here's a principle that changes how we think about buying equipment. The purchase price of a machine is a tiny fraction of its total cost. The real cost, often more than 90%, is the labor of the person operating it over its lifetime. So when we choose equipment, the question isn't what's the cheapest option. It's which machine lets our team work fastest and safest. A machine that costs 20% more, but allows a specialist to work 30% faster pays for itself quickly, and keeps paying back every single shift. This is why HPC operations invest in backpack vacuums, auto scrubbers, and spray and vac restroom systems, not as luxuries, but as smart financial decisions. It's worth pausing to look at what inefficiency actually costs, because it's more than just slow work. Wasted time on each shift, multiplied across a whole team, across a full year, adds up to thousands of rands in lost productivity. Inefficient processes lead to worker fatigue, which leads to corners being cut and quality dropping. That causes rework, and rework is 100% wasted time. And a physically exhausting, frustrating work environment drives staff turnover, which is one of the most expensive problems a cleaning operation can face. Efficiency and quality aren't competing goals. They're two sides of the same coin. So let's bring Module 1 together. We've redefined our professional identity, from traditional cleaner to health and asset preservation specialist. We've grounded that identity in 3 core scientific principles: dwell time, cross-contamination prevention, and ergonomics. We've introduced the 4 pillars: quality, health and safety, efficiency, and sustainability, as the framework for everything we do. And we've looked at the economics of efficiency, understanding how production rates, workloading, and smart equipment investment make operations both more effective and more fair. This is the foundation everything else in this course is built on. In the next module, we move from principles to practice and look at our first operational model, team cleaning and the specialist approach.